welcome to the short tutorial on Nicolson Method. This is a part of my class on computational fluid dynamics. So the Nicolson Method is an example for solving parabolic equations. For example, the heat transfer equation through a rod, as you know, is a parabolic equation. So generally this is the equation, the form of the equation, and we try to solve this by various methods. One of the method is Nicolson method. The problem is like this: if this is a rod, and if you know the temperature at here and here, then our question is, what is the temperature at the internal nodes? Okay. This is the heat equation I was talking about, and these are the boundary conditions, and this states that at x is equal to 0 and time is equal to t, temperature is T0. That means if this is the rod, then this is at T0, that means here the U is T, and here the U is T. This is the boundary condition. If the length of the rod is L, right? So this is the initial condition, and this is the final condition based on the x coordinate. However, the time stays at t is equal to t, right here. But when the time t is equal to 0, that means this is the initial time, t is equal to 0, then at x, that means at any point inside this rod, u is function of x. This is the temperature u at any point x inside this rod at time t is equal to 0, the initial time. So that is, this is 0. Then this u is described by a equation which is a function of x. Okay, so this is how the problem is. And the Nicolson method proposes the rectangular formula, which is k is equals to alpha a square, and this is u of e. Now, how to apply to solve this? How to apply this and this to solve the heat transfer equation through a rod? Let us explain it with the help of an example. Okay, let us see. This is the problem. Find uij. As you know, I is the unit of x and j is the unit of time. So at I is equal to 0, 1, 2, 3, 4. That means if this is the rod, right? If this is the rod, let us take this length as h. That means L is equals to h. Then what they are saying is here this will be the x is equal to 0 at a uniform distance, that means del x. This will be 1, this will be 2, this will be 3, and this will be 4. So all these, the distance between this and this, this and this, this and this, and this and this is same. These are uniform. So which is represented by the term del x. And j is equal to 0, 1, 2 means at t is equal to 0 second, and then t1 means suppose it is after del t second, let us say it is 3 second, at t2 means after 2 del t second, that means it is 6 second. This del t is same between the t and t1, t1 and t2, and let us assume that this is 3 seconds, right? So they are saying that what will be the temperature at u, I and j. I means x, j means t. So these are all I. This is the I1, I2, I3. This is I0, this is I. And j is the t. So this j1 is the j0 is the 0 second initial time. After del t is passed, this will become 1. So this will become 0 plus del t. So whatever value of del t is there, j1 will be that. And j2 will be 0 plus del t plus del t. So whatever value is the del t is, multiplied by 2 will be j2. So he is saying that find the temperature at 0, 1, 2, 3, 4. That means x equal to 1, 0, 1, 2, 3, 4. That is the internal nodes, including the edge nodes. These are the edge nodes. And we represent this point as 0 and this point as 4. This is the final point, this is the initial point. So they are saying including the initial points, what will be the value at 1, 2, 3? That is what the question is. And they want to know the temperature at these 3 points at the initial time, that is 0 second, after first installment of time, and after second installment of time. That means del t to del t. Now it is also said that when u at any point x and at time t is equal to 0 at the initial time, is u can be represented by this equation. However, at u at x is equal to 0, this one, and at time t, so this at time t means at any time t, this will be 0. That means the h temperature is 0 degrees centigrade, and also h at any time at any point x equal to h. This h means x equals to h. That means the entire length of the rod, which I have assumed to be h. So at the point x is equal to 0 and at the point 0 plus h, that is the final point, the temperature is 0 degrees centigrade. That is given at any time t. But at the initial time 0, this u at any point x will be represented by x by 3 within bracket 16 minus x squared. This is what the problem is. So let us see what we can do to it. So first thing is you have to create this matrix. This is the first step. You have to create this matrix. This is your j, this side, and this is your I, this side. So 0, 1, we have to find the temperature at I is equal to 0, 1, 2, 3, and 4. And at time scale t is equal to 0, 1, and 2. So from the boundary condition we know at time t, at any time t, the edge is at 0 degrees centigrade. Both the edge. This is the left hand edge and this is the right hand edge. This is the initial edge or beginning edge. This is the final edge or ending edge. So if this is the rod, this is the initial edge, this is the final edge, and at any point, at any time t is equal to 0, 1, 2, they will be at 0 degrees centigrade. Right? So this is I is equal to 0. At I is equal to 0, at any point t, t is equal to 0, t is equal to 1, t is equal to 2. This edge is at 0 degrees centigrade. So you can write 0 here and also in the final point you can write 0 degrees centigrade. So these two are solved. Now we also know that at t is equal to 0, the boundary condition state that condition state that u at x 0 is equals to that equation, that is x by 3 within bracket, that expression, this is function of x. So if you put the value of x as 1, 2, 3, then you will be given as 5, 7, and 8. Okay. So if you put the value as 1, 2, 3, then this equation will give you the value of u as 5, 7, and 8. But at t is equal to 1, t is equal to 2, nothing was given in the problem, in the question. So we write it as it is: u1, u2, u4, u1, u2, u3, u4, u5, u6. So these are all unknowns. We do not know what is the temperature here. From the initial condition or boundary conditions given, we can find out that at x is equal to 1, 2, 3, u will be 5, 7, and 8 from the function given in the boundary conditions. And the edges will be at 0 degrees centigrade. This is also given. So you have to solve, or you have to do something to find the value of u1, u2, u3, u4, u5, and u6. This is your job. So how to find it? As recommended by Nicolson, any u, this one, can be found out by the rectangular equation. What is the rectangular equation? The rectangular equation is this: 1 by 4 within bracket a plus b plus c plus d. Here you go like this. First diagonal in the left hand side, this is first diagonal, will always be the a, and second diagonal in the left hand side will be always be the c, and in the right hand side, upper row, upper diagonal will be b, and lower diagonal will be d. This is the nomenclature, or this is the rule we follow. Upper row left hand side a, upper row right hand side b, lower row, although this is not lower row, this is the same row, but we take it as, we assume it as lower row. So lower row left hand side c, right hand side d. So you put the value of a, this will be 5. You put the value of b, this will be 8. You put the value of C, which is the unknown U1, you put the value of D, which is the unknown U3. So this will give you the U2. And then you have to find out what is, because U1 is also unknown. So what is U1? So as you can see, A will be this one for U1. Then B will be 7. And C will be 0. And D will be U2 for U1. For U3, A will be 7. A will be 7, B will be 0, C will be U2, D will be 0. And for this U4, A will be 0, then B will be 2, C will be 0, D will be U5. Right, and so on for U5 for U6. So there will be 6 equations with 5 unknowns, which you have to solve by the binary equation method. And the result will give you the value of U1, U2, U3, U4, U5, U6. Right? Sorry, there will be 6 equations, 6 unknowns. So here, this problem is very simple with the help of Nicolson method. So if you have given the rod, and they will ask you that what is the temperature here, 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 and if you know the boundary temperature, this H temperature, this is the 0 and this is the final. So suppose you know what is T0 and you know TH, this will be given, and it will this will also be given that what is U at any point X at the time scale T is equal to 0, but the initial time. This will also be given with the help of a function of X. Now the question will be to find this one. So to find it, straight away draw the matrix. And as you know, as you can see, when I is equal to 0 and I is equal to 4, these two are the edges, right? These are the edges. So at this time, what happens is, at any point t, at any time scale t is equal to 0, t1, t2, this will be 0. These boundaries are at 0 degree centigrade all the time. This is given, already given. And but for any other time, for at time t is equal to 0, that initial time, x is given by this function, right? So from which we have found out what is this I is equal to 1. What is the temperature at I is equal to 1? Here, this is I is equal to 1. Sorry. I is equal to 1. And the temperature can be found out by this equation, which is for this case is 5. Then for I is equal to 2, then for I is equal to 3, right? And this can be found out for only for this initial time, because this equation is given for the initial time. So what was found is that all the other value of U or the temperature at I is equal to 1, 2, 3 at for the time scale 1 and 2, these are all unknown. That means this is U1 is unknown. U2, these are time scale 1, time scale 2. Initial time we know from this equation. But first time installment and second time installment, we do not know anything about that, about the temperature in the internal note. So we write it U1, U2, U3, U4, U5, U6. So always go like this. U1, U2, U3, complete. Then come U4, U5, U6. right? Don't write 1, 2, 3, 4, 5, 6. Don't rotate. Come parallel. 1, 2, 3, 4, 5, 6. Correct? So for this, if you want to solve this, you have to create 6 equations to solve the 6 unknowns. Here 6 unknown is there, 1, U2, U3, 4, 5, 6. And you can use that Crank-Nicolson equation, rectangular equation, to find the find 6 equation. After solving the 6 equation, you can find the 6 unknowns. How to do it? This equation states you the temperature is equal to 1/4 of A plus B plus C plus D. Okay, so here how to find A? A will be your, suppose this is the unknown, U1. So this will be A. Upper row, left hand will be A. Upper row, right hand will be B. Same row, left hand will be C. Same row, right hand will be D. So this will give you an equation for U1. Similarly, you will prepare an equation for U2. Then for U3, then for U4, then for U5, then for U6. That means you will have 6 equations, 6 unknowns, solve it, and you'll find what is U1, U2, U3, U4, U5, and U6. So, so this is what we have explained. So as I already said, there will be 6 number of equations to find the U1 to U6 besides the boundary conditions also. So you have to solve the equations, complete the matrix, and you will find U at each point X for each of the time instruments. T is equal to 1, 0, 1, 2. So this is overall what Crank-Nicolson method is. And Crank-Nicolson method is another way to discretize parabolic equation, parabolic partial differential equations. Advantage of this equation is it is a little bit simpler compared to the iterative methods, and it tries to solve the equation by this simple equation, this one. So, but yes, boundary condition. As this is the solving method, you are solving 6 equations to find 6 unknowns. So, as you are using the binary method, the problem is that you will retrieve 6 specific solutions only, and for only for one time only, and they may or may not be the optimal solution. You do not know. But in case of iterative method, with the help of the relative absolute error, we can find out or we can identify the most optimal solution for these equations. This is the difference between Crank-Nicolson method and this iterative methods. So with this, I close.